Alright, so welcome back to your favorite inorganic tutor YouTube channel once again. Today we are going to look at how we can differentiate these inverse trig functions. Particularly, we will be looking at the sec inverse, the cosec inverse, and the cot inverse. Alright, we have already dealt with the sine inverse, the cos inverse, and then the tan inverse. So you can watch out for the previous video and you get that one. Right. Now let's look at how we can prove this particular sec inverse, right? So we either use the left hand side to prove the right hand side, or we use the right hand side to prove the left hand side here. So let's sec inverse of u equals y, right? So here you multiply both sides by sec, right? So you multiply both sides by sec. So sec times sec inverse of u should be equal to sec y, right? Now we are interested in u, right? So we cancel the negative with the positive, right? So cancel this and this, then we have u equals sec y. Here we apply the chain rule on the right hand side, and then we differentiate this part as well. So when you apply that, you're going to have the u over the x should be equal to differential of sec y is going to be sec y tan y times the differential of the inner function, which is going to be dy dx, right? Now we are interested in the dy dx, so we do divide both sides by sec y tan y. Right? So this cancels this, and then we now have the y over the x should be equal to the u over the x all over sec y tan y. We are mathematicians, so we need to simplify this, right? So let's simplify this so that the expression becomes so nice. So we have here the u over the x divided by sec y tan y. Of course, this is over 1, right? So we can see that we have the y over the x equals the u over the x times 1 over sec y tan y, right? So let's position this well, bring this here, and then send this here. So we can say that we have y over the x equals 1 over sec y tan y, then the u over the x, right? So from here, let's name this equation 1 and this equation 2, right? So we have this here sec y tan y here, right? But from the identities that we learned, we can see that we are having 1 plus tan squared x equals sec squared x, right? But here we are interested in the tan, so we take this particular one, right? So we take but 1 plus tan square. In this case, we are using the variable y, so we say tan square y should be equal to sec squared y, right? So we send the 1 here, and then we maintain this here. Sec squared y minus 1. So we take square root on both sides, and then we have then y should be equal to the square root of sec square y minus 1, right? From equation 1, we said that sec square y, sec square or sec should be equal to u, right? So we do that substitution here, and then we have tan y equals u, right? U squared minus 1, right? So now we can call this equation 3, right? So now we have equation 2 tan y here, and we have sec y here. So we put the sec y, now replace it by u, and then you replace the tan y by this, right? So we have dy dx equals 1 over the sec now is u, so we have u, but it must be in an absolute value, right? Then the tan is square root of u squared minus 1, then the u over the x, right here. Ladies and gentlemen, we have been able to prove this formula, right? So that is the right formula over here. So the assumption is that you just make sure that this notation that you do here follows a systematic method, right? So if you do that, then the next thing that you do is your substitution and the derivative of the trig functions, as well as the identities of the trig functions. All right, so let's move on to the next inverse trig function. Alright, so our next inverse trig function is going to be cosec inverse of u, and that is giving us 1 over absolute square root of u squared minus 1 u over the x. Right, so we want to prove whether this particular derivative that they are given, the formula that they are given, is right or not. Good. So let's go ahead. So as usual, we take let cosec inverse of u equals y, right? So as usual, now we are dealing with cosec inverse, so we multiply both sides by cosec so that we can go away with the inverse. So we have cosec times cosec inverse of u should be equal to cosec y, right? So here we can see that this positive takes off this negative, so we have u equals cosec y. So now what we do is that we have to remember our derivative of the trig functions. All right, so we know that the derivative of cosec is negative cosec cot y, right? So we have this part is going to be du over the x equals derivative of cosec, and that is negative cosec y cot y times the y over the x, right? So we are interested in the dy dx, right? So we divide both sides by negative cosec y cot y, then this part too by negative cosec y cot y, right? So this takes off this, and now we have dy over the x equals negative, or du over the x all over negative cosec y cot y, right? So let's do proper presentation here. So we have du over the x divided by negative cosec y cot y. Of course, this is over 1. So we have dy over the x equals du over the x times negative 1 over cosec y cot y, right? So now we bring this here and then we send this back here. So we have dy over the x equals negative 1 over cosec y cot y times du over the x. Right? So let's consider this as equation 1 and then this as equation 2. Now, we have to look for an identity that can fit into this function down here, right? So we have cosec y and then cot y. So we have to look for cosec because we have to look for cot y because we have cosec y over here already. So cot y, we can find it here at the third identity, right? So we have 1 plus cot square y equals cosec squared y, right? We are interested in the cot, right? So we take this to this part and then we have cot square y equals cosec square y minus 1, right? So we take square root on both sides and then we have cot y equals square root of cosec squared y minus 1, right? But earlier on we said that cosec should be y, cosec should be u, right? So we have that one replacing this. So we have cot y equals this square root of u squared minus 1, right? Very good. So now what we do is that we substitute equation 1 and then equation, let's name this equation 3. Substitute equation 1 and then equation 3 into equation 2, right? So we have, let's bring that up here. So now we have dy over the x equals now negative 1 over cosec y is over here as u, but then it should be absolute, right? So we have absolute u times cot y, as usual we found over here as square root of u squared minus 1, right? Then times du over the x. Very, very simple. So right from here we came up here and then we proved the formula over here. Ladies and gentlemen, we have been able to prove the cosec inverse formula. Very, very simple. Just have to follow the derivative of trig functions and the identities and you are good to go. Let's look at the final aspect of the trig, the inverse trig function, right? So our final inverse trig function over here is cot inverse of u, and that is negative 1 over 1 plus u squared du over the x. This is going to be very, very easy for us to do, right? So let's look at how we can prove this as well, right? So as usual, we have cot here, so we have, let's cot inverse of u be y, right? So we are interested in the u and then the cot being positive, right? So we multiply both sides by a cot on both sides. So we have cot times cot inverse of u should be equal to cot y, right? So now we can see that this negative takes off this positive, and now we have u equals cot y, right? So we differentiate both sides, right? We use the chain rule here, and then we use the normal differentiation over here. So we know that when we differentiate this, we are going to have du over the x. Then when we differentiate cot, we are going to have negative cosec squared, this time is y, then du over the x. Very, very simple. So now we proceed, and then we are interested in the dy dx. So we divide both sides by negative cosec y, negative cosec square y. So this takes off this, and then we have dy over the x equals du over the x divided by negative cosec square y, right? So here, what we do is that we have to do proper presentation here. So what we do is that du over the x divided by negative cosec square y, and this is of course over 1, right? So we have dy over the x equals du over the x times negative 1 over cosec squared y, right? So we bring this here and then we send this here so that our presentation will be so nice. So we have dy over the x equals negative 1 over cosec square y times du over the x, right here. So let's name this equation 2 and come here and name this equation 1, right? So right here we have to look for an identity that can fit into this, right? And we have it right here. It's just simple. We're just going to substitute the whole of this in place of the cosec squared y. So we say that but 1 plus cot squared y is equal to cosec squared y, right? So what we do is that we substitute the whole of this in place of this. But earlier on we said that cot y should be u. So we do that substitution before we send it there, right? So we say that, right? So we can say that du over the x, dy over the x is equal to negative 1 all over 1 plus cot squared y times the u over the x. But cot is u, right? So we have dy over the x equals negative 1 over 1 plus u squared du dx, right? So easy, ladies and gentlemen. We have been able to prove the inverse trig functions, and that is the cot inverse, the cosec inverse, and the sec inverse at this point, right? Don't forget to press on the notification bell, and then I'll keep you updated. Bye.